Now let's look at exercise 2.11 to 11. We're going to be focusing on perfect squares today and factorising instantly. Now I'm going to do a redundant step here, an extra step. I know when I'm factorising a quadratic, especially if it's a monic quadratic because there's a 1 in front of the x squared. I'm factorising a quadratic, I'm looking for numbers at times to give 16 and add to give minus 8. So in this case the numbers would be minus 4 and minus 4. Because minus 4 times minus 4 is 16 and minus 4 adds with minus 4 to give minus 8. But that is actually, because it's the same bracket, written as a perfect square because it's the same bracket multiplied by itself. Let's go through the second question. A little bit trickier. Oh, let's try this. I'm going to treat it like normal. There is a shortcut, but you're not going to often recognize it, so let's treat it. 4 times 25. Let's treat it like our normal factorizing questions. 4 times 25 is 100. For some reason that's better. So I need two numbers at times to give 100 and add to give 20. And the numbers will be 10 and 10. When the numbers are both the same, it means we've got a perfect square in play here. Now if I factorize this using method 2 from last class, each bracket's going to start with a 4a. I'll have to divide by 4. And each bracket gets a plus 10. Now 4 doesn't go into each of the brackets because 4 doesn't go into 10 nicely, so I'm going to think of that 4 as 2 times 2. So 2 into that bracket and this 2 into that bracket, which means I end up with 2a plus 5, 2a plus 5, or 2a plus 5 squared. So effectively, whenever you're factorising, if you end up with the same number that multiplies to give the last one and adds to give that one, or the same number that multiplies to give 100 and adds to give 20, you end up with a perfect square question. Now let's have a look at a difference of two squares. So whenever we have a difference of two squares, effectively we have a minus sign because difference means there's a minus sign between two things that can be squared. X squared is actually x times x, so it's x squared. 16 is 4 times 4, so it's another way of writing 4 squared. So when we have a difference of two squares, the shortcut that we've learnt in years 9 and 10, x times x gives me my x squared, 4 times 4 gives me my 16, and one bracket is positive and the other bracket is negative, and it doesn't matter which order you put the positive or the negative in. Let's look at part B. There's a minus sign between two terms and it's a difference of two squares because 6 times 6 gives 36, so 6a times 6a gives 36a squared, and 1 times 1 gives 1. So effectively 6a plus 1, 6a minus 1 is our answer. When we go to part C, it's again a difference of two squares because there's a minus sign between the two terms and each term can be written as something squared. The order is important. Notice that the x is at the end of the question, so the x will be at the end of the bracket. 3 times 3 is 9. X times x is x squared. One bracket gets a plus, one bracket gets a minus, and we're finished. Now part D is a much more challenging question. So for part D, let's just break that up there. For part D, what I actually have is something squared minus something squared. So it's a really glorified, tricky difference of two squares. So when I get these ones, I like to use square brackets. It's going to be hard with this pen because I can't write with fine detail, but we'll try. Each bracket begins with a minus 3 in brackets. Where did the a minus 3 in brackets come from? A minus 3 in brackets squared. Each bracket ends with, well, there's a b plus 1 in brackets squared, so each bracket ends with b plus 1. I'm not changing any signs, I'm writing exactly what was in the bracket. Now, I'm going to put a plus and a minus because it's a difference of two squares. One bracket gets a plus and one bracket gets a minus. Now comes the tidying up stage. Inside this first square bracket, I notice that that a is being plussed to no other a's, so I just end up with a. The b has no other things it can be added to, and it's a positive b because there's a positive in front of that bracket, so it's plus b. Now I need to focus on the numbers. See how there's a negative 3 there? And there's a positive 1 there, and we're plussing those two brackets, so negative 3 plus 1 gives negative 2. And that's that first bracket done. Now the second bracket, well, we start with an a again, because there's an a there and there's no other a's for it to add to. There's a b there, but in front of the bracket is a minus, which turns that b to a minus b. Now I focus on the numbers inside the second square bracket. I've got a negative 3 and a positive 1, but that positive 1 is affected by the minus in front of the bracket, so it's actually negative 3 take away positive 1, which is negative 3, take 1, which is negative 4. Now, I don't need to have square brackets there and there. If they're rounded, it means the same thing, but that is my factorized answer for factorizing that particular difference of two squares.